Welcome to the channel. Despite I haven't updated this channel for quite some time, I've still been working on the robot. One of the biggest tasks has been to replace ROS completely. I had ROS nodes basically running on individual Raspberry Pis for each of the arms, the wheels, the neck, the vision, everything. But the latencies were quite bad. I mean, you give a command and you wait, and then something might happen. And then you wait, you send another command and you wait, and it's happened faster. So the latency of the ROS system, and I isolated it to be really too dependent on the ROS, was quite bad. So I tried ROS 2, but it's too much in the beginning of development, so many problems that I just decided to skip it. Instead, I decided to use another commercial protocol, data transfer protocol in the Ethernet, which is supposed to have a much smaller latency. I know some other software and equipment that already use it, so I had experience and it seemed to be quite good. So I implemented that on the Raspberry Pis in each of the actuators and all the units and removed ROS completely. And it actually works very well. I set a command from computer, push button, and whatever's needed done, moving the robot, arms, neck, whatever, and it works very, very well. At least with my human ability to perceive latency, I cannot say that there's any disturbing delay between sending the command and the actuation actually happening. Here is Zeromq. This is basically the messaging library I used in the robot with the Raspberry Pis to replace ROS completely. I can really recommend it. It was very easy to implement all kinds of client server systems, kind of information that would be distributed in all kind of, basically it had all kind of various ways to do connectivity and data transfer between nodes in the robot. You know, very similar way, actually, and I would say an easier way than with ROS. In the end, I had to basically remove ROS from all the small Raspberry Pi and so on servers, remove all of them basically, and replace them with my own code using the Zeromq libraries, test all of them. I also changed some things in the arms, as this upper arm was, as I always planned it, working fine. This one had problems in some of the actuators. Now it's more like working horizontally, not touching the ground. Because sometimes when you touch the ground, and I don't know what happened, but one of the actuators I get kind of impact and it always overloaded and just shut down itself and became lame. So I did a bit of modification to the structure of this arm. So now all the insides are basically here. So I'm using these USB battery packs. There's Ethernet switches. I also replaced the Wi-Fi connections which I was using as a robot with cabling, as there seem to be so much problems with it and bad latency. So Ethernet switches. Here's the Wi-Fi to connect externally to the robot. Power supplies to different things here. I put some writing into each one of the power connectors, which computer is connected to which. Also, some of the actuators, like the one for the arm, they're now all below this one in the bottom floor. So there's more of the actuators all placed down here, the frequency converter. So let's start it up. Here's the switch for the wheels. This is basically the arms and neck. We don't need them now. Emergency switch off. Okay, now I need to connect to the robot's own network. Connect. Actually, instead of the protocol which I mentioned, for the wheels, I decided to just use a telnet server, which connects to the USB port and through that to the drive. And instead I made a script into the drive itself, Robotech drive, which basically handles most of the commands and simplifies the commanding. So let's choose the robot wheels, load, and then open. Okay. So here we are. So first I'm sending one variable, which basically you can choose. One means the robot is in position control mode, basically relative position control mode, and 0 means it's in speed, closed loop speed control mode. Here I'm basically given in advance actuators how many pulses of the sensor to move forward. 4 is right side wheel from the behind of the robot, and 5 is the left side wheel. And with this command, var 3.1, I'm changing a variable to 1 that will add the simultaneously load both of the values of 4 and 5 into the drive simultaneously and start executing the command. And after it's executed, it will return the value of the variable to 0. So there it moved.